Hello and welcome to 6.1 Notes. Today's lecture we're going to cover three concepts or three areas, and the first two are most definitely a review, and the third one might be something new that you haven't seen before. But again, the first two, ratios and proportions, are definitely a review. Okay, we've gone over both ratios and proportions in the past. I've lectured on them. We've had activities on them and homework problems, and you've had to use them to solve problems, things of that nature. So it's most definitely a review. But I believe ratios and proportions are very important. They are very important for this chapter on similarity. So I need to make sure that we've covered them well and that you understand ratios and proportions. So with that said, if you first thing I want to express or say to you is that ratios are usually expressed in lowest form, okay, in simplest form, I should say, lowest terms or simplest form. So if you have something like, say, 6 feet over 12 feet, for one thing, ratios are unitless. They have no units, so you must have the same unit on the top and the bottom, in the numerator and denominator, in order for that to happen, right? In order for them to divide out. So first concept you need to know is that you have to have the same units or dimensions on the numerator and denominator. And then if you do, you must, for one thing, and then when you do, I should have said, when you do, then they divide out, okay? And you just have the numbers. Because remember, ratios are unitless. So 6 to 12 reduces to 1 to 2. So we would call that 1 to 2. And the second thing I want to go over is that that's how we say it when we talk about ratios. We don't say 1/2, we say 1 to 2. Okay, well, I'll go over that a little bit more in a bit. But again, in ratios, we say 1 to 2. This lecture is largely going to be application, so there's not too many theorems or postulates or rules to write down, okay, just maybe one at the end. But like I said, it's mostly application. So let's begin. Simplify the ratio. Okay, you can write that down. And we're going to simplify 24 yards to 3 yards. And remember, at any time you can pause this video, rewind, whatever you need to do. So we have 24 yards to 3 yards. What I like to do is write them down as if they were a fraction. That helps me out. And also we have to make sure that these are the same words, right? Because the words divide out as well as the numbers. And obviously yards is the same word as yards, so they can divide out. And we're just stuck with the numbers, 24 to 3. Which simplifies to 8 to 1. So we would call the answer 8 to 1 or 8 to 1, right? And actually write the TO, 8 to 1. And we can also use a colon, but we still say in words, we say 8 to 1. Okay? All right, another problem, 150 centimeters to 6 meters. So again, I like to write one on top of the other as if they were a fraction. But we have here 150 centimeters divided by 6 meters. So I obviously do not have the same units. Okay, so I can't divide them out. If I take 150 centimeters and divide it by 6 meters, what is that? What is the answer going to be? Is it going to be in centimeters? No. Is it going to be in meters? No. It's sort of like if I took 6 oranges and divided 6 oranges by 2 hammers. What do you get? Three what? 3 oranges? No. 3 hammers? No. So you can't do that. They have to have the same units. And if they don't have the same units, like in this problem, then you need to multiply by a conversion factor. Okay, so you need to know how to do this because you will be responsible for problems like this. So you have to multiply by a conversion factor. My conversion factor is this. I'm saying that there are 100 centimeters in a meter, and that's going to be how I convert. So there are 100 centimeters in a meter, and I'm choosing to put the meters in the numerator because I'm noticing that I have a meters in the denominator, and I want those words, those units, those dimensions to divide out. So that's why I'm putting it on the top. I have to put it on the top, or the numerator, to divide out with that one in the denominator. So now I can do this. I can divide all the words out, all the units out, right? and I'm just stuck with the numbers. So I have 150 over 600, which reduces to 1 to 4. So we would say that the answer is 1 to 4. This is in a ratio of 1 to 4. So 150 centimeters to 6 meters in lowest terms or simplest form is 1 to 4. Or we could say 1 to 4, or we could say 1 to 4. Okay? So let's move on to this problem. Okay, we have the perimeter of a room is 48 feet, and the ratio of its length to its width is 7 to 5. Find the length and width of the room. Okay, so step 1 will be to write the expressions for the length and width. And since we know that the ratio of the length to the width is 7 to 5, we can represent the length by 7x and the width by 5x. Okay, so let's explore that a little bit. We have this rectangle, and we know that it's in the ratio of 7 to 5. That's not saying that this is 7 feet to 5 feet. Okay, we don't know the exact measurement. We just know that it's in that certain ratio. So let's sort of ignore the fact that it has to come out to 48 feet perimeter for a moment. Let's just say if we just know that this is in a ratio of 7 to 5, what is the actual length going to be? Well, it could possibly be 7 inches, right? We could have just multiplied everything by 1, and we can get that. That is a possibility. That is in the ratio of 7 to 5, right? Or it could be multiplied by 2 in each case, in which case we have 14 by 10, right? Or it can be multiplied by 3, in which case it's 21 to 15. Or we can multiply by a fraction even. It doesn't have to be a whole number. It can be maybe 1.2 and 1.2, in which case it would be 8.4 by 6. So we don't know what the actual length and width are going to be, but we do know they're going to be in a ratio of 7 to 5. Well, as you saw, we multiplied by 1, we multiplied by 2, we multiplied by 3, we multiplied by 1.2. But what is the actual answer? If it has to be in a ratio of 7 to 5 and add up to a 48-foot perimeter, what is the actual number? We don't know. But we do know it has to be the same number. Okay? If they were two different numbers, like a 2 and a 3, that would change the ratio. So that's impossible. It can't be two different numbers. It has to be the same number. And what is that same number? Well, we don't know. So we're going to just call it x. So we have that the length is 7x and the width is 5x. The length is 7 times some number, which we don't know yet, and the width is 5 times that same number, which we don't know yet. Okay?